Hey guys, welcome back to another fun geometry lesson. Today we're starting topic 5, which is all about, more triangles, and specifically in this lesson, in the first lesson of this unit, we're going to look at perpendicular bisectors and angle bisectors. So our two objectives for today is to use the perpendicular bisector theorem to solve problems and to use the angle bisector theorem to solve problems. So obviously before we can do that, right, we have to know what is the perpendicular bisector theorem and what is the angle bisector theorem. So those, along with the converse of those, are our theorems for today. And our new vocabulary is equidistant. So hopefully you have your note packet, this little guy right here. In the very back of your note packet are your terms and theorems. And so we're going to jump to the back of this packet where it says terms, and we're going to fill out our first definition. So the first term, actually the only term that we have for this lesson, is equidistant. So equidistant just means at equal distance, okay? So two line segments, or the distance away from something to two different things is the same length. So for example, if I have, let's say, a point A and a point B, and then some other random point C. Okay, if the distance to AC is the same as the distance to BC, so let's say that line and this line are the same. Remember, that little tick mark means equal, right? So those two distances are the same. Then I can say that the line segment AC, or really let's do this instead. Let's say the distance from A to C is equidistant to the distance I guess I should say of B to C. So A to C and B to C are the same distance, so they are equidistant. And that's actually the only term that we have for today, but we will be using this word equidistant to define our theorems. So we're going to jump down now to the next page where we have our theorems and postulates. All right, so we're going to start here by looking at the perpendicular bisector theorem. So a couple things that we have to review, right? We learned about perpendicular bisectors first semester, but just as a review, if I have a line, holy moly, I can do better than that. Right? Come on, Miss G. Okay, so if I have a line A to B, and I have a perpendicular bisector, I'm going to label it C and D. What makes it a perpendicular bisector? Okay, what makes it a perpendicular bisector? One is these two lines are perpendicular. They cross at 90 degrees. Okay, the other thing is it bisects this line AB, meaning it cuts AB directly in half. Okay, so what this allows us to do is once I have my perpendicular bisector, any point along this perpendicular bisector, any point at all, I'm going to call this point right here. Oh, that's not a very good color, is it? Let's call it this point right here. Let's call it C prime. Okay? But I can pick any point along this perpendicular bisector. The distance from the ends of my line segment to that point is going to be equidistant, is going to be the same. So here I can say that A to C prime is equal to or is congruent to B to C prime. So if AB is bisected, right, and CD is perpendicular, any point along this line is equidistant. So I can also like pick a random point here, say D prime. I actually don't like where I wrote that. Let's do it down here. D prime, right? If I draw a line here to B or to A, it would be the same thing. A to D prime is congruent B to D prime. And I can continue to pick points, right? I can pick this point and it would do the same thing. I can pick this point. I can pick a point way down here. It doesn't matter. Okay, as long as CD is that perpendicular bisector, the endpoints will be equidistant to any point on this line. The converse of this is just exactly the opposite. And this is just saying, if I have my points again, let's go A, B, and then let's just pick a random point up here, C. If AC and BC are equal, so if AC is congruent to BC, then point C is on the perpendicular bisector. And hopefully I can fit this. Ooh, it was tight. Perpendicular bisector. So what that means is if A to C and B to C are equidistant, then any line I draw, or if I draw the perpendicular bisector, right? We can connect B and C. But all it means is that C is going to be on this perpendicular bisector. So point C has to be on the perpendicular bisector. So it's literally just going the other way. It's just, again, saying, hey, if I have a perpendicular bisector, any point on that is going to be equidistant to the two endpoints. Now we're going to look at the next two, which is angle bisector and the converse of the angle bisector. Very, very similar idea here. This just says, and this is a typo, if a point is on the angle bisector of an angle, this should say angle, sorry, then it is equidistant from the two sides of the angle. So, you can draw it much better by hand in person, not on here. So, if I have, I'm going to call this D. If I have an angle bisector, remember an angle bisector means it's a line or a ray that divides my angle in half. Bisect means to cut in two. Okay, so it cuts this angle in half, meaning that this angle right here and this angle right here are the same. Okay, these are the same angles. So what this tells us now is any point along this line, and let's just call this, I don't like it there, let's call it right here. Call it point C. So point C, if I draw a line to the side of the angle, like so, and then I draw a line to this side of the angle, like so, that tells me that, let's call this A and let's call this B. That tells me that this length and this length are the same because C is on the angle bisector. I could do another point out here and draw it and draw it. It would be the same. Any point along this angle bisector. Okay, so again, if CD, it's a ray, is the angle bisector of angle ADB, then I can say that AC is the same distance, equidistant to BC. They are congruent. So this length right here is the same as this length right here. And then the converse is just the exact same thing going the other way. Okay, so this is saying if I have an angle, I'm going to draw the same angle, something similar, D, let's draw a point C, okay, A and B. So, oops, my B didn't turn out as well as I wanted. All right, A and B. So this says if the distance, if AC is congruent to BC. So let's say I'm given this. Then I automatically know that D to C is an angle bisector. Then DC is the angle bisector of angle ADB. So what that means is that D to C, right, is the angle bisector. So then I'm able to say, hey, this angle and that angle are the same. So it's just, again, going back and forth and being able to go back and forth here. I think what you'll find is when we actually do problems of this, you'll be like, oh, this is not so bad at all, at least hopefully. So we're going to go back to the beginning of the packet, 5.1, and we're going to go through these problems and figure out how we can use these theorems. So let's look at example 1 here. It says Mr. Lee wants to park his ice cream cart on Main Street, so somewhere along this road, so that he is equidistant from the entrances of the amusement park and the zoo. So here's the zoo entrance, here's the amusement park entrance, and he wants to be equidistant. Where should Mr. Lee park? How can he determine where to park? Well, if he wants to be equidistant, let's say between this point and this point, he can find the perpendicular bisector. Because the perpendicular bisector, every single point on the perpendicular bisector is going to be equidistant to the zoo and the park. So to find the perpendicular bisector, right, we can first of all draw our segment. And then I want to draw a line that is perpendicular to this and also cuts this distance in half. Unfortunately, we're just going to have to estimate. So something like that, right? So it cuts it in half. This distance is the same as this distance. And since he wants to park his ice cream truck on Main Street, it's going to be right here. Right? So that's where the perpendicular bisector intersects Main Street. So this will be equidistant to the park entrance and the zoo entrance. So he should park his truck, or his cart, excuse me, his cart at point T. So just keep in mind that the perpendicular bisector, the distance to the end points is always going to be the same. So using that idea, we're going to move on now to example 2, where we're going to apply it. And it says, what is the value of AD? So A to D. So this is what I'm trying to find right here. So in this triangle, AC is the perpendicular bisector to BD, right? It splits B and D in half. They're both 11, and it's perpendicular. So that means that this distance, B to A, and the distance of B to D is the same. So that means that this 6x minus 10 and this 3x plus 2 are the same. And since they're the same, they're equidistant, right? That means that they are equal in length. So I can set them equal to each other. So I know that those lengths are going to be the same. And I'm going to solve this for x, right? So we can subtract 3x. I get 3x minus 10 is equal to 2. We can add 10 to both sides. 3x is equal to 12. Divide by 3, divide by 3, and I get x equals 4. And that's great, but that's not what the question was asking. The question is asking, what is the value of AD? So when I look at my diagram here, AD, A to D, is 3x plus 2. But I know what x is now, so I can take that value and I can plug it in for x. 3 times 4 is 12 plus 2. So the length of AD is 14. And since we don't know if it's inches or feet or centimeters or whatever, we just write 14 units. And that's it. You guys have 2 triads here. Actually, there's 3 triads. Excuse me. You have 3 triads here. So I want you to pause the video and give these a shot, knowing perpendicular bisectors, right? That the base is going to be split in half, and the distance to a point on the perpendicular bisector is going to be equidistant to the end points. So just use that information, see if you can solve A, B, and C, and then when you are ready, you can go ahead and hit play on the video, and then we'll go through them. All right, so let's look at our first example, example A. It says, what is the value of WY? So right here. So looking at this, I see that ZW is the perpendicular bisector, 1, because it's perpendicular, and also because X to Z and Y to Z are the same length. So that tells me that Z is on the perpendicular bisector. Since it's on the perpendicular bisector, it bisects XY in half. So 5n minus 2 is the same length as 2n plus 7. So we should have gotten 5n minus 2 is equal to 2n plus 7. And then I can just solve. So we can subtract 2n, gives me 3n minus 2 equals 7. I'm going to add 2, 3, oops, I wrote A. I don't know why I wrote A. 3n equals 9. Divide by 3, and I get n equals 3. Okay, but that's not what it's asking, right? It's asking what is the value of WY. So WY on the diagram is 2n plus 7. And now I know the value of n, so I have 2 times 3 plus 7, which is 6 plus 7. So I get that WY is equal to 13 units. So hopefully you got that one. It was nearly identical to the one above it. The next one, I'm going to go ahead and clear this so I have more room to write. The next one's a little bit trickier. It's asking what is the value of OL. And it's really hard to, there's a lot of stuff going on here. So I kind of thought, for me personally, it was easier if I separated these 2 diagrams. So I drew the big triangle, right? And this is 17 and 17. And then this is 14. This is n. Okay. So I drew the big triangle, and then down below, I also drew the small triangle. So all I've done is I've kind of split this, right? And so that here's N, here's L, M, and O. Okay, so I looked at the big triangle and I said, okay, this is a perpendicular bisector because JK and LK are both 17. So that tells me since JN is 14, that LN is also 14. Okay, so from N to L is 14. Oops. Now, since NM and LM are both 9, tells me M is on the perpendicular bisector. So if N to L is 14, then 0.0 splits that in half. So that means that this is 7 and this is 7 because it splits that 14 in half. So the value of OL is 7 units. So the tricky part on this one was just being able to kind of visualize and break apart these two triangles so that we could clearly see what's happening. The last one here, question C, says, what is the value of FG? Okay, so let's look. E to H and G to H are the same. And HF is perpendicular to the base, so H is on the perpendicular bisector, which means E to F and G to the F are the same length. Well, since EF is 6, GF also has to be 6, or FG. So FG is equal to 6 units. That one didn't require any calculations at all. That's good. So hopefully we feel good about using the perpendicular bisector. If you have any questions, just make sure you reach out. We're going to switch gears now, and we're going to look at the angle bisector theorem. So that's that other theorem we talked about. Remember just saying that if L to J is an angle bisector, then the length from J to K and the length, from L to K and L to M are the same. So let's look here on example 3. It says, what is the value of K to L? Well, I'm looking in L to J. Do you see? It's really hard to see, but there's these little curves here. And I'm going to maybe draw them bigger so they're like that. That tells me that these two angles are the same. Since these two angles are the same, L to J is the angle bisector. Since LJ is the angle bisector, it's cutting that angle in half. That tells me that the length from L to K is the same as the length from L to M. So what that means then is that since those lengths are the same, one of the lengths is 2x plus 3, and the other length is 4x minus 11. And since they're the same, you set them equal to each other. And we can solve. I'm going to subtract my 2x. And I get 3 is equal to 2x minus 11. I'm going to add 11. I get 14 is equal to 2x. Divide by 2. Divide by 2. I run out of space. That's okay. X is equal to 7. But again, it's not asking me what is x. It's asking me what is the value of from K to L. Well, KL is equal to 2x plus 3. But I know the value of x now. So I can plug it back in. So 2 times 7 plus 3. 2 times 7 is 14. And 14 plus 3 is 17. So KL is 17 units. And there it is. We have a try it here. For the try it, I'm going to scroll down just to show you here. For the try it, A has values that are given, and you'll need to plug those values in. And then for question B, the values are totally different. So even though it's the same image, you'll have to if you plug in your values, like for example, HI here is 7, right? And IJ is 7. And then I'm told that HGI, so this right here, is 25, right? So once I'm done with question A, I'm going to have to erase these numbers and then fill in the new numbers for question B. So just be aware of that. So go ahead and hit pause on the video, give A and B a shot, and then when you're ready, hit play and we'll go over them. All right, so I already filled in the values that were given on question A. And the question is asking, what is the measure of angle IGJ? So this right here is what it's asking me to find. Okay, well, since IH and IJ are the same, that tells me that I to G is the perpendicular bisector of this angle. So that means that this angle right here and this angle right here have to be the same. So since I know that HGI is 25, then I can confidently say the measure of angle IGJ is also 25 degrees. And then for question B, we're given totally different information here. So let's fill this in. I'm given here that HGJ is 57. So this whole thing right here is 57. I'm given that IGJ, so this one right here, is 28.5. And HI is 12.2. What is the value of IJ? So I want to know, what is the value of IJ? Okay, so let's look. In order for IG to be the perpendicular bisector, these two angles have to be the same. Well, if this one's 28.5, I can do 57 minus 28.5, which actually gives me 28.5. So that means that this angle right here is also 28.5. So now I feel, and we can kind of get rid of that. Now I feel confident in saying that IG is the perpendicular bisector because these two angles are the same. So then if HI is 12.2, that means that IJ is also 12.2 units. If, just to show you, if here I got like 30 or something, then IG would not be the perpendicular bisector and we wouldn't have a way to figure out what IJ was. So those two angles have to be the same in order for it to be a perpendicular bisector. Sorry, an angle bisector, not a perpendicular bisector. All right, one last problem and then we're done with this lesson. Example 4 says, given that the measure of angle BAD, so this right here, I don't really have room to write it, so I'm going to do this, is 9x minus 16. And CAD, which is that angle right there, is 3x plus 20. Find the measure of BAC. So I want to find the whole angle. And I'm told here that the distance from B to D and the distance from C to D are the same. So that lets me know that D is on the angle bisector, which means BAD and CAD, those two angles, these two angles right here, have to be equal. So if they have to be equal, I can set them equal. So one angle is equal to the other angle. And I'm going to solve, so we can minus 3x. 9x minus 3x is 6x minus 16 equals 20. Let's add 16 to both sides. I get 6x is equal to 36. Divide by 6, divide by 6. X is equal to 6. So that's great, but it's not asking me what x is equal to, right? It wants the measure of angle BAC. So the whole thing. Well, the measure of angle BAC is my 9x minus 16, so this guy right here, plus my 3x plus 20, which is this guy right here, right? It's these two angles added together. So if I simplify this, 9x plus 3x is 12x. Negative 16 plus 20 is positive 4. And I know what x is. X is 6. So I have 12 times 6 plus 4. 12 times 6 is 72 plus 4, which gets me 76. So that lets me know that the whole angle, the angle of BAC, is equal to 76, and don't forget your units, and in this case the units is degrees because it's an angle. All right, guys, that's it for 4.1 or 4-1. If you have any questions on angle bisector theorem or perpendicular bisector theorem, or if one of these examples didn't make sense or you need help on the homework, anything at all, just make sure that you reach out and advocate for yourself. Let us know, and we're more than happy to provide all the help that you need. Hopefully you feel good. If not, reach out, and I'll see you guys later.